In this video, I'm going to prove that if a, b, and c are integers such that c divide a, b, then c divide the greatest common divisor of ac times the greatest common divisor of bc. So to prove this, we have to use theorem 2.4.1 to deal with this. So let's start to prove. So we have to assume that. Let's assume that ABC are integers such that C divide AB. Then try to show that C divide the greatest common divisor of AC and the greatest common divisor of BC. Now what can we do? I think we have to use this theorem. That means that if you have the greatest common divisor of AB, so they exist integers x and y such that such that the greatest common divisor of AB equal to AX plus BY. Okay, so the next thing I'm going to do is to let D to be AC and M to be the greatest common divisor of BC. Then we apply theorem 2.4.1. So by theorem 2.4.1, what do we have? So they exist. I gotta use x, y, u, and v such that the greatest common divisor of AC equal AX plus CY. And the greatest common divisor of BC is BU plus CV. Okay, so the next thing we're going to do is to take a look at this one right here, C divide AB. So since C divide AB, so what do we have here? So we can use divisibility, right? So there exists integer Q such that AB equal CQ. Okay, so once we have this one, let's try to multiply the greatest common divisor of AC and BC. Okay, so what do we have right here? We gotta have the greatest common divisor of A and C times the greatest common divisor of BC. So we gotta have AX plus CY times BU plus CV. Okay, and then we multiply it, so it turns out to be AX BU plus this one here AXCV plus multiply this term CY. Give me a second. CY BU plus CY CV. Okay. Next one, let's use algebra to deal with each term of this. So we gotta have AB XU plus AC XV plus, okay, I gotta write BC YU plus C square YV. Okay. Then we know that C divide AB. That means that C is a factor of AB. So AB becomes CQ. So it turns out to be CQ xu plus ac xv plus bc yu plus c square yv. As you can see, all these terms have c as a factor. So I gotta factorize c from out of these four terms. So we gotta have c q xu plus a xv plus b yu plus c yv. Alright? And this number is an integer, right? These numbers are integer. Okay? So by divisibility, right now we have the greatest common divisor of AC and times BZ being C times an integer. So what do we have? So by divisibility, we're going to have that C divide the greatest common divisor of AC times the greatest common divisor of BC. Okay? And that's it for this proof. So we have proved that if A, B, and C are integers such that C divide AB, then C divide the greatest common divisor of AC and BC. And that's it for this video.